Hello everyone, welcome to Coding Made Easy. Today we are going to see the problem, count good nodes in binary tree. Given a binary tree root, a node X in the tree is named good if in the path from root to X there are no nodes with a value greater than X. So what does that mean? And we need to return the number of good nodes in the binary tree. So what does that mean? So suppose if we take a node 3. So what are the nodes from root to leaf for 3? 3, 1, 3. There are no nodes greater than 3 in this path. So 3 is a good node. What about 1? 3, 4, 1. So there are two nodes which are greater than 1 in this path. So 1 is not a good node. For 5, 3 and 4 are smaller than 5. So 5 is a good node. So let's see how we can solve it. So the root can also be -1. So first, we need to think, what is the value this node needs to get to understand if it's a good node or not? Basically, we need to know the maximum value node from this root until this leaf, or until this node. So if we get that maximum value, and if our current node is greater than that max, then greater than or equal to that max, then that node is a good node. Otherwise, it's a bad node. So here we are going to send -1. Here we are going to send -1. And here we are going to send 1. So the maximum value from root until 3 is 1. So 3 is definitely greater than 1. So we know 3 is a good node. So 3, it would return 1 because it knows 3 is a good node. And for 1, it knows 1 is a good node and its left child has 1, left subtree has 1 good node. So it'll increment that 1 because to include its own value. Similarly, it's gonna give -1 here, and that is gonna give 4 here. It's gonna pass 4 here. So for 1, it knows it's not a good node because the maximum value has been 4. Its self value is 1, which is smaller. So it knows it's not a good node. So unlike this 3, which is returning 1, here the 1 will return 0. Here it'll return 1 because it knows it's a good node. So 4 it knows is a good node. So from left subtree it got 0, right subtree it got 1. So left subtree value plus right subtree value plus self. Self is 0 or 1 based on if it's good or not. So 0 plus 1 plus is 4 good node? Yes. So it's 0 plus 1 plus 1, 2. So 2 plus 2, it's going to return 4. That is the solution. So what is the time complexity? We iterate every node once and only once. So it is big of n. Space complexity, it's due to the recursion stacking, which is also big of n. Let's go to the solution. So we have a good nodes. So we are passing in this one, we are passing in different values of max, which is not in the question. So we'll create a wrapper function. So to begin with, we are passing in root.val -1 because for -1, we'll pass in -2 because this value is for sure always a good node. How can we make sure this is always a good node? By passing in a number smaller than this. So then for sure this becomes good node and we'll pass in the root value to left and right. So that's what we do. That's the max value. So initially we'll keep the return value to 0. If it's an empty node, then there are no good nodes observed. So if If the current value is greater than the max value we have seen till now, then that's a good node. Then we have to collect the good nodes from the left and right subtrees. So what is the max value we are going to pass? It's the maximum of current value and the max value. Then we are going to return out. Oh, I missed the equal to. So if root dot value is greater than or equal to max value, because the condition is the value is strictly, if the value is strictly greater than x, then that's not a good node. So if there was a 3, 4, 4, this 4 is also a good node. So as long as the value observed until the node before the leaf is greater than or equal to the current value, we are deeming it as a good node. Okay, the solution is accepted. Uh, Thank you everyone for watching. Catch you up in the next video. Bye.